Well, hello there. Welcome to SkyTour LiveStream West. We're open tonight for business, and we're going to see about checking out what we can with the nearly full moon. I think we have one more day until it's full, and the person that knows that is right with me here. Daryl, how's it going?
Hi, Mark. Fine. You?
I'm fine, thank you.
And the moon is at opposition, truly full at 6:01 a.m. tomorrow morning, Mountain Time, or 8:01 a.m. Your time, Eastern Time.
Yeah, and right around
Yeah.
that time, we're going to be getting hit full force with a hurricane. So I figure we better get the stream in now. Because we got ourselves a little bit of a dilemma here. We've got some heavy wind and rain coming. So I guess we just have to live with that, right? So that's what we're gonna do.
It's the alternative.
Yeah, I know. But welcome, folks. I want to say hi to Chantel. Hi there, Chantel. Hey, Marianne and Rob. Thank you for coming out. Dagger's here somewhere in the background, I know. And Canada Boy is here. Hi there. How you doing? CND boy. Nice to see you. And because the moon is out, the sky is going to look a little bit kind of bluish to us, even though I'm using a special filter to knock most of that away. We're going to end up still seeing a bit of it. We do have our telescope connected to our planetarium system, so we can actually steer around the sky using that if we wish. Let's actually select Antares here, and let's go to Antares. So we're going to tell the telescope to go there, and let's make sure that it works. It's a good test. You'll notice over here, you'll see the telescope should start moving. There it goes. And then while it's looking for it, it's going to probably go straight to Antares. So let's go in and check it out. And look, there it is. That's Antares right there. And the telescope is centering it up, getting it in there. And I'm happy that the telescope is doing what it should do. You can see this halo around Antares. That's something that, like I said, I'm going to get rid of that programmatically. I'm going to write a piece of software that'll help get rid of that. It might work, it may not. Tara, hey, welcome. But we're working on it, And Farva is here. How you doing there, Farva? Haven't seen you for a while. Rascally, how's it going? PG, hello to you too. This is Antares, the heart of the scorpion. And if we move over a little bit, we'll actually see that we actually have a... sorry, that's the wrong way. I'm just going to jog the telescope a little bit because that's perfect. Because right there on the right side, we'll see something else. And let's remove the speed here. Just drop the speed a little bit. Drop it down. Okay. The telescope's responses are down here in this little window that you can see. Alright, and now I'm going to take us a little bit more to the west, moving Antares near the edge of the field. And when I do that, you'll see that this other object is coming in. Now our field is 2 degrees across and 1.5 degrees tall. So it's actually kind of a wide field view that we have, which is kind of nice. A wider field view. Alright, and I'm going to change the time here to give us let's say 6-second time. Alright, so that's 6 seconds. And for those that are just joining us, thank you, Farva, man, you're the man. This is me down here, hello, in the lower left. Right above here, you see the telescope in the observatory, actually out in the Arizona desert, 2,500 miles away from me. This is the telescope control system up here. This is the live view. We have a light year of new capabilities, a light year. of new capabilities here. With this new system, we have a dedicated astronomy camera that we're using, and it's just really, really beautiful. Really, really beautiful. So the camera system over here, all right. Okay, the ones that we care about are this one. This is the camera controls, exposure time. That's very important. We're going to use that. And down below here we have gain. All right, the gain control is very useful as well. We're going to set the gain to 350. That's a good average for what we do. What is that? That's sort of like the sensitivity. Like a camera has ISOs of 400, 800, 1000, all the way up to 6400 or 8000 in some cases. And in the case of our Sony, we had a 409,000 ISO. So that was the sensitivity. Well, this camera is more sensitive than the last camera we were using by far, and it was really, really, really something, And Ajo, how you doing? Yeah, you're in daytime where you are. But
where is that person?
What's that?
Where is that person?
Let's find out. Ajo, where are you? I'd like to know. So, while we're waiting for him, we actually are going to show you. This is Globular Cluster Measure 4, right? And it's not really this close to Antares, but it just looks that way. And what we can do with this camera, okay, again, the things when we bring up the camera panel, the exposure controls and the camera controls, and this gain is very important. Also down here, thermal controls. The nice thing about this camera is that it has a thermoelectric cooler. Now that means that the camera is going to wick away, in other words, get rid of all the heat on the sensor. Now it's currently 83 degrees in the building out there. That's Fahrenheit. And I show you that by looking at our focusing system that we have. And if we go to the temperature tab in the focusing system, you can see that the temperature is 83.1 degrees. Or okay, 88. It says 87.9, 88. Okay, well, I got you. Okay, so that's the temperature in there right now. So it's close to 90. But the camera is being cooled right now as we speak. I turned on the cooler. And as it does that, we're going to see less and less artifacting and garbage on the screen. The target temperature is minus 10 Celsius. And since turning it on, it's gone down to 21.8 Celsius. 0, remember, is freezing. And it's going to go to minus 10, so 10 below 0 Celsius. Right? And that's going to be a really, really chilled and cold sensor, which is going to make this a very, very clean data. But for fun, what I'll do is we'll do what's called live stack. Now, live stack is a very interesting technique for where we actually take these 6-second pictures and we start stacking them. And by stacking them, we can actually see some really amazing detail that begins to show up. All right, and so you want to stack. You want to start doing any playing around with the data here after you start cooling it down. See, the sensor's not fully cooled down, so we have a center spot that's still a hot spot. The edges get cooled down before the center, so the center takes some time. So we get this little artifact in the middle until the sensor cools down fully, because this is still a little bit warmer and we're seeing noise in here, and that shows up as this light area. Okay,
May I ask a question?
Yeah, go ahead.
Can you give a layman's explanation of how it's cooling?
The thermoelectric cooler is actually, well, the way thermoelectric coolers work is they analyze the electrical current that's coming from the sensor. There's spurious signals and there's actual signals. What they're trying to do is wick away and take away all of the spurious signals. But to do that, the actual temperature has to be brought down. Now there's a fan in there, and it's actually hypercooling the sensor with this fan system. And as far as the actual cooling mechanism, I'm not sure how this particular thermoelectric cooler works. I think they're pretty much all the same. But it's something that I don't know how this particular camera's cooler works specifically. But thermoelectric coolers in general are trying to wick away the heat from the sensor by using this special fan system. And they know that it generates a lot of heat. That if you're standing in front of the camera, you can actually feel heat coming out of the cooling fins where the camera is. Yeah, because it's actually doing that cooling process. And we're at -5 right now on the sensor, and we're continuing to drop. All right, and so we're just working at it. These two screens are the primary ones we use for doing this, and it looks really crazy, looks wild. But you know what? It's just showing you how this actually works, you know. And it seems confusing, but it's not that bad. It's not that confusing. Now, see, what we can do is we can remove that green, or that blue tint rather, from the image and try and get it back down to more of a natural look for space, you know, the darker space. And by doing that, we can find ourselves playing with these little sliders over here just to kind of balance things out. Now, we can do it that way, and that's sort of close. But we can also hit this button here, which does sort of an auto process like that. And you can hear my dingo behind me. She's on the floor, and she's in the middle of a dream. I think she's chasing a kangaroo. I don't think she's ever seen a kangaroo. So we'll drop some of the blue out and drop some of the green out. We've stacked 32 frames already, by the way. So just in this little short amount of time, see? 32 frames, 34 frames, you know? So, you know, this is kind of cool. And for those of you... Oh, thanks, Farva. For those of you that actually had seen the link, I made it a sticky on my Facebook page and on the SkyTour LiveStream Facebook page. It's at the top. It's a link to these photos. The photos we just took and this stack. When I do this, when I say pause right here, and I'll do it right now. Say pause. All right. And then I say save. All right. And when I say save, now you'll see up here, it saved this FITS file. That's an astronomical format. Then I'm going to save it just as you see it. Save as seen. Okay. And in about 30 seconds, this file will be up at that link under today's date, and you'll be able to get down there and see it. All right. So it's nice. So this is now, I have a server for you to see things live as they come in. So, and that's how it's done in big observatories. You know, as soon as the picture is taken, it's shipped off to a server where processing can really begin. This is not processed. This is a kind of a semi-processed image to just sort of look pretty. All right, but if we wanted to actually do a real processing setup, then to do that, we would actually end up spending a lot of time working on the images after. And that's just what we'll do. That's just what we'll do. You know, but this is Messier 4, like I said, and the location of the Messier 4 is right next to Antares, which is right over here. And Antares, of course, is the heart of the scorpion. How do you know? Well, here you go. Here is the scorpion. All right, and I will also show you the constellation art. Okay, so there's the constellation art. All right, and so Messier 4 sits right next to Antares. Now I gotta say that since the moon is near full, it means it's out right now. So we do have a nearly full moon out there. All right, and that's problematic, but we'll make do.
If you get a chance later before you go to bed tonight, or if you're up early tomorrow morning, go out and take a look at the moon. The moon, there's another bright object right next to the moon. That's Jupiter, and it's unmistakable. And Interestingly, Jupiter was in opposition 2 days ago on the 19th, and so now the moon is in almost the same place, and it's in opposition in the morning, and that's not a coincidence.
All right. You make sure you do that, guys.
Don't go now, but look before bedtime or when you get up in the morning.
Yeah, it's probably a better time. So yeah, so we're playing around here in Scorpius just for a startup, and luckily, I don't know if remember last night when we did this or the night before, we had clouds that just seemed to show up out of nowhere. That's because as the desert cools off at night, these clouds will form over the desert right at that spot. So those clouds were not actually there before. They formed over the desert. So I'm going to just quickly go and look and see if we're in for that again tonight. It may be true that we'll see some. But if you recall, we waited it out and we ended up seeing the clear skies, and eventually in the morning it was just beautifully clear. Of course, I wasn't streaming in the morning at that time, but we're going to see right now. I'm doing a 20-second shot. The moon's going to be pretty bright, but we should see the sky. Look at that. Okay, what you're seeing here, I'll just maximize that so you can see it. So it's totally clear. We don't have any clouds, so that's fantastic. Very pleased about that. So we'll be able to be doing some astronomy tonight. I'm looking forward to it, and I'm really glad you guys are here. Hi, Isabella Melamed is here from Sofia, Bulgaria. She is great. Have you seen her latest take on the Gamma Cygni Nebula that we took the other night? She took the stack and processed it and came up with her own version of what it should look like. And I have to say, she did a fantastic job. It was very nice, Isabella. I also sent you a message, which I think you saw, about other programs you could use to try and do some of the things you're trying to do. And here's Bonnie on Ahata 77. How are you? Good to see you. So I usually like looking at globular clusters because I like to check the focus. And we do have a problem with the telescope that's I'm going to fix now. It's going to be I'm going out there on the 7th of September, and I got to come back probably in about 7 or 8 days after that, maybe 10 days if I can push it. And I want to be in the observatory working on getting the optics configured properly. I know it looks beautiful. I know that it looks great, and I know that some of the images were just stunning, but it could be even better, guys. It could be even better, and I'm going to see about that happening. PG, you still coming to Pine Bush? Because I'm still talking there. All right. Okay, so now, let me... I don't want my thing to do... Okay, we got that. And I'm going to get rid of the stack, and then you'll see this image go away.
When you look at the two of those, Antares there is about 550 light years away.
Yep.
And when you look at M4, it's over 7,000 light years away.
That's right. And what Daryl's getting at is that when we look at the universe, it's always in 3D, and you can always think of it as looking into a time machine. You're seeing Antares as it was 500 years ago. It might not even be there now. It may have gone supernova for all we know. And then Messier 4, you're seeing it as it was 7,000 years ago. So right now in the sky, Messier 4 is not quite in the same position. It's moved a little bit. It's moved 7,000 years worth of time in the sky. But slowly, as that light train comes to us, it'll eventually move to the place we saw it, and then it'll be that much further along. Because everything you see is back in time. This is how it once was. That's how you have to think of every single object you look at, even the sun. You're seeing the sun as it was 8 minutes ago. You're not seeing as it is now. Nothing in the universe do you see as it is now. Not even the moon. It's just over a second that you see the moon back in time.
Excuse me.
Crystals and Cats, how are you? Hello. Okay. What I'm going to do now is I'm going to take us... Oh, I really liked how we were able to check stuff out up in the Cygnus area. And I feel like I want to just jump up in that region because I really want to get up to some of these other objects up here.
Suggestion?
Suggest a way.
You just had it on your screen. It's off to the lower right. Look at M10 in Ophiuchus there.
Yeah, that was over here on the right.
Yeah. It's another globular.
Yeah.
There you go.
Okay.
If you're going to waltz your way up to Cygnus.
Yeah, let's try it. And you guys can watch the telescope over here. You'll see that it's actually going to be moving here shortly in just a minute. Let me do one thing. Let me bring this down a little bit more so you can see more. Because the scope has this very long dew cover on it, so it looks a lot bigger. And that'll disappear off the screen. Alright, so here we go. So, Messier 10, globular cluster. And this one is literally about 14,000 light years away from us. So,
twice as far away as M4.
Yeah, telescope on the way. The telescope, you'll see, it'll start moving. The telescope's going to actually go to a bright star first. And then it's going to take that bright star, center it up, and then it's going to jump from that in a very precise way. And I'm doing 6-second exposures. I'm going to drop this down to 1 second. Okay. Alright. Now, the nice thing is, we can tell what that star is, even though we don't know exactly what it is, because we don't know which one the telescope's gonna go to. But we can actually do what's called plate solve, and we can solve for that location. If I stop the process and we just solve for that location, it would tell us what star that was. We would know. Okay, and right there, guess what's there? That's Messier 10 right there, centered right in the field. And to see that in true form, let's do this. And while I'm doing this, our guiding system is acquiring a guide star, and that's really helpful. All right, I'll do 8 seconds here.
I don't remember ever looking at anything in Ophiuchus with you before.
Really?
Have we?
Holy cow, I guess not. Wow, look at that. That's really pretty. Alright, well, let's stack this too. Let's do a live stack and check it out. And we're going to clear this first. That's the previous stack. And now we're stacking again. And we can just pin this here. Right, and then we see the full screen. We can also zoom it a little bit too. You know, we can actually do that, which is kind of nice. Let's say go to 33%. Yeah, now we can start to resolve it. We see all the stars in there. And let's bring up the stack for a minute and see if I can make it look a little different.
I dare say if M10 was as close as M4, it'd be much larger in the sky.
Yeah, it's probably
Brighter too.
yeah, it's probably got a lot more stars than M4.
Hey, full moon night, we can always look at globular clusters.
I know. And they're always
They don't
beautiful.
all look the same either, people.
No, they don't. And Daryl knows because when he looks at Messier 13, there's an interesting feature in there called the propeller that he often talks about. And the propeller is definitely something that is a feature that basically shows up as like some dark areas within the cluster. And they form a really interesting line of a line of blackness, I should say, a void. It's apparent. It's not. It's just an apparent look. All right, let's get this down here. This is a little bit red. Okay, let's drop it down.
Hey, our friend Lee Klingler is here again.
Hey, Lee Klingler, how you doing? And very Lucia Campos from Brazil. How are you? So good to see you all. One Man's here too. Nice to see you, One Man. Thanks for joining us on this wonderful Arizona night. I'm in Connecticut, riding the telescope 2,500 miles away in Arizona. So I gotta tell you, I'm a little nervous because, you know, it's that far away. You got all that equipment out there in the middle of the desert, and, you know, you get nervous. You know? Yes, sirree. This is good. 19 frames have been stacked on this. That looks good. I've always liked this song. Yep. And in that time that I did that stupid head bobbing, we had 22 frames stacked. 23. So, this is cool. And I'm going to save this stack right now. Alrighty. And then I will save it as it is.
If you like introspective music, have you ever heard Keith Jarrett,
Yes.
piano player?
Absolutely.
Oh, I love that guy's work.
Awesome.
What I have of his is really old, but like the Colon concert and stuff like that.
Mm-hmm.
Staircase, I think another one's called.
Okay. Alright, let's do this. And now let's just try a plate solve here. Basically, this is a field of view in the sky, and based on the star patterns, the telescope should be able to tell exactly, or the software should be able to tell exactly where the telescope's pointing to. So this line will go from yellow to green, saying that it found exactly where we are. So and there we go. It found it that fast. See how fast that was? That's pretty quick. Alright, so I'm going to just get a copy this over. It says we're at 1657.44 and we are at 1623.55 by the telescope's view, and we're at 45:29:45, and it thinks that no wait, oh sorry, duh, -4 7:45, and we're at -4 1:54. So that's not far off at all. The center of our field is there, so that's pretty good. That's pretty good. We always have the ability to use that to be able to get this center of the field. And if we wanted to, we could just put those numbers right in here and sync the telescope. It's like aligning it all over again. And I'm really impressed that I was able to use the telescopic system and this technology to completely align this telescope from all the way out here. You know, because I lost the alignment one night and I was totally destroyed. I thought, oh no, how am I ever going to align this again? And I realized, wait, I can do this through the software. But I just have to find something I know okay, like this, and center it up, and then just make my coordinates those coordinates. And I tried it, and the first time I tried it, it took a long time to find something I knew, but once I found something I knew, I could do it. But the trouble was that I didn't have the ability to do this plate solve technique, where this will just look at the pattern of stars and solve for where we are based on the pattern of stars. Now I have that. I have it actually in West, and I have it in East as well. I have it in the East system as well. The East system's behind me. Actually, I'm doing maintenance on it, but if I just bring this up and you look behind me right now, okay, that's the East system right there, behind me over my shoulder. It's another 10-inch telescope, but it has a 5-inch Richfield refractor sitting on top of it, and those two are going to be in the building out here that we're actually building right now. So while the building's being built, and it's actually replaced the dome, as pretty as the dome was, it wasn't practical, because I had too many problems with the dome trying to be centered properly, and everybody knows I gotta go move the dome, because I couldn't rely on the dome moving technology. The thing I'm doing now is much different. I'm using what are called linear actuators, and it's going to take the roof, if it's on the building, it's going to take the roof and just lift it and drop the roof right off to the side on arms made of steel. I have the linear actuators, they work beautifully, and I did a model already of the observatory, digital model, it works, and I have all the lengths, everything, and so we're building that out here as well. 8 foot by 8 foot, because it's only going to house the one remote telescope. So that's pretty cool, and I just believe in the whole remote system, you know. It just makes sense to me. You know?
I remember before you had to jump up and run outside to move the dome. You were down in the dome with it, and
yeah,
you were freezing your buns off at night.
Yeah, and there was a couple times that I did it by myself, and I got confronted by coyotes, and one time a bear. So I'm okay to stay inside, thank you, on nights like that. It was very cold out there, you know, and that was another problem. Well, there we go. This is just beautiful. Oh, wait, we've been stacking all this? No, we haven't. Okay, good. That's very good. Okay, so let's go and look at, since we're here at M10 now, let's go up and follow the Milky Way. Follow the Milky Way. And we come up, and let's go to a beautiful little planetary nebula that everybody loves to see. I love this planetary nebula. Alright, and we're going to go there right now. Watch the telescope. Okay, while the telescope is ramping up to go there, I'm going to go and set our time down to 1 second again. Okay, so this is our high precision star. Guess what star that is, guys? You probably don't notice because it's not sticking around long enough, but it's Albireo. The orange star is down here, and a blue star to the upper left is beautiful. And then Albireo goes away because Albireo was our location star, and now it's moving us to the nebula, which is right here. Did you catch that, Daryl? It went to Albireo.
I did. Sorry, I'm having a coughing fit.
That's okay. I'm having a blood orange Pellegrino, blood orange and black raspberry Pellegrino sparkling water.
I went and grabbed a cup of water myself.
So let's see.
But it is in a red Solo party cup, so.
Red Solo cup, come fill me up. It's a party.
I'll pretend it's a party.
Yeah.
It's the apple core.
It's the dumbbell.
It's the dumbbell.
Yes, the apple core. I know the name well. All right, so this will be fun because, and look, I'm being turned loose, man, because it's a clear night, and we do have a moon out. But it's really good to take these objects on a moonlit night, so you can see how the performance works on a moonlit night, almost a full moon. Okay, so by the way, for the record, at a second exposure that we would do out here, this nebula would not show up at a 1 second exposure. But this telescope is 25 times faster than the other telescope. But we'll change that. We're going to change all that. Okay. 10-second shot of the Dumbbell Nebula. And pay attention to the colors, especially. Alright, check out these colors. Wow. Those are pretty colors. You know? And again, I'm zoomed a little bit. The actual size of the field is much larger than this. If I go to the full size, this is how big it is. Okay, see, it's a little smaller. But it's beautiful. And let's live stack this one. And we're going to clear it and start again. Okay, stacked reset. And the first picture will come in here momentarily. There it is. Let's wait for a second stacked image. Should come in here momentarily. There it is. And now let's bring the background down a bit. Make it a little darker. Okay, and what if we do this? Yeah, too much. Let's do this. Alright, let's go back to here and do some of this processing and see what this does. Yeah, you can see the colors really clearly there. That's beautiful.
You know, I just started calling M27 the apple core a while back, and
Yeah?
I was watching, I forget who it was, some astronomy vid on YouTube a day or two ago. They called it the apple core.
Well, okay. Alright, so the bright sky here is because of the moon. But we can actually zoom in again. Let's do 40% this time. Yeah, see, we got, you can see, that almost looks like I need to play around with the focus a little bit, doesn't it? I think we're gonna do some focus. Alright, let's get rid of the stack. We'll come back to this stack. I'm not gonna save it yet. And we'll do a 1 second photo as a standby. We'll do this to, there we go, to get our focusing tools active. Let's do this, get the focus tool active. And we're going to do focus assistant. And we'll do, there we go. Alright. Alright. And while I'm focusing, I'll just bring up this music. And you grab a star and you look at the focus numbers here and you change those. And we pick a direction. Let's head out. And look at the direction they move.
You want to get that down in the green, don't you?
Yeah. I'm not sure I can get all the way down into the green because of the collimation problem, but I want to get as close as I can. And I'm approaching that now. With the collimation error, I think this is the best it's going to get right now. So I'm going to
I usually say howdy.
Huh?
Cipher 2.
Oh.
I'm confused. Don't pay any attention to me.
Right. Don't worry, Daryl. Everybody thinks the world of you. Okay.
My mom thought I was cute.
Well.
Or she told me so anyway.
Well, I think she meant it. Alright, remember last time when we checked, we saw the cloud suddenly appeared. I'm going to just do another quick shot. I'm going to first change the settings though. Instead of a 20-second shot, I'm just going to do a 10-second shot. 10 seconds is all we need. So I'll do, it's measured in milliseconds, so it's 10,000 milliseconds. Okay, we're still clear. Excellent. Okay. Let's go back now and see if we can dare to take a 20-second shot.
Good night, Tara.
Oh, Tara said she was going to try and come in. Tara, thank you for coming in. Sleep well. I know that you said you were tired earlier. So you have a good night. And I will talk to you tomorrow probably. Okay, here we go. 20-second shot coming in. See if it's too bright with the moon. No, but I can see the focus isn't right. You can see the collimation error very clearly when you look at these stars. You see you have a dot and then this weird thing up top. That's an error in the collimation of the mirrors. The mirror with the lens on the end, so I have to fix that. However, you can see the central star in here. So effectively this is focused, but the collimation error renders it pretty bad, you know. But don't worry, we're going to fix all that. Actually, I was thinking of teaching Tara how to do the collimation. I know she can. Look at that, huh? Man. What a beautiful image. Just pushing a little. Okay.
That video on YouTube I saw a day or two ago about the dumbbell, it was another, they showed a very deep image.
Yeah.
And, you can see all sorts of stuff around the outside that,
Yeah.
you know, it takes like a professional telescope.
Oh, I love it.
Very complex.
Yeah. It's really pretty. Let's do a live stack of this and see. I'm just going to clear this actually, because this was the previous stack. And then we wait for 2 images to come in before we actually start trying to do any processing. Alright. Remember, we're doing 20-second shots now. Wow. Most excellent. Okay. And then we'll wait for the second one to come in. And then we'll play with it. it is. Actually, let's see. Most of the data is right there. Yeah. Okay. We want as much of the data as we can get. That's cool.
Finally got pop out chat to work.
What?
Well, I can stay on your screen and still read chat.
Oh, cool. Oh, you popped it out. Okay.
Yeah.
Very nice. We have 6 frames stacked here so far. A dumbbell on a nearly full moon night out there. Hey there, Bobby Burgess. Yeah, the storm, the center of the storm is going to go right over my county. So, this may all be gone tomorrow. Nah, I don't think so. I've been through hurricanes before.
Well, it's like class 1, isn't it?
Yeah, which is not that bad, but bad enough.
74, 75 mile an hour winds, I think.
74 for hurricane class 1, yeah. Yeah.
Heck, we call that a spring day here.
Well, you know, the thing is, with hurricanes, unlike tornadoes, the tornado winds are focused and extremely devastating near the storm. But just a short distance away from that funnel, it drops off precipitously. Hurricanes, on the other hand, they have large masses of air that are all moving at those high speeds for hours on end. So the damage gets done. Trees get blown over, wires get hit, you know. There could be some significant damage. But I think most of the damage that will come will be down at the shoreline. I noticed there was a storm surge possibility of in excess of 10 feet down there, which will flood almost every single house that's on the shoreline here.
Yeah. Well, we get windstorms here that are, I mean, they can be really scary sometimes here.
No, I believe
You'll
it.
get like sustained winds well over 100 miles an hour.
Yeah.
Some places like Boulder get it worse than we do here in the Springs.
Is that because of the wind coming off the Front Range?
Yeah, how it gets funneled down the mountain or whatever.
On the Flatirons?
That might be. Boulder's infamous for the windstorms they have.
Yeah.
And they're just sustained winds, and those can be pretty trippy all by themselves.
I believe it. So you stacked 13 here. Let's take a look at how it looks. Not bad. It looks pretty nice. And we're still zoomed, obviously. Zoom a little more. This is 42. This is 43. Yeah, this is really pretty. Yeah, it's just, like I said, I got to collimate. I tried to do it when I was there, and unfortunately, I thought I had done it right, but then we had a problem where when the telescope went haywire one day, it slammed down into the bottom of the mount, and the thing sticking off the front crashed into the mount, and it didn't break anything, but it could have done this. Like, this is the main mirror, and this is the lens. Okay, it could have gone and cranked it, just enough.
Yep.
That's really exaggerated, but it could have done that just enough to cause this that we're seeing here. Now that we have the dew shield on there, though, the dew shield is a big steel ring, basically aluminum ring, actually, that doesn't budge, and the telescope has crashed into the mount, and the dew shield has hit the mount and hasn't budged, which actually acts as a protectant to this large lens and camera sticking off the front end of the telescope now. Eventually we're going to trade this mount for what's called a GEM, a German equatorial mount, and we'll be able to rest easy that the telescope will never ever strike anything that it shouldn't strike. Look at these some of these beautiful red stars. Those are very likely red dwarf stars. The most plentiful stars in the entire universe are these red dwarfs. And they actually have most of the planets around them of all the types of stars out there. And they're very low temperature stars, but they also, because of low temperature, little percolators, they live trillions of years, not billions like the sun. These little red stars are also ultraviolet flare stars many times. They actually give off copious amounts of ultraviolet flaring, and so that could sort of sterilize, a young planet. If there's life, if you're expecting there to be life, well, it could sterilize the planet, So I don't know. Let's hope that there isn't a problem. After all, if you think about it, you look at all the variation of life on our planet. You know why we have that variation? Because of mutations. Mutations led to evolution and natural selection, where certain species were mutated into something else, and those conditions that caused the mutation might have brought this species to a place where it could actually survive better, and thus it would last and survive for long term, whereas something that couldn't survive long term would die out. And that's natural selection, naturally selected by nature, by chance. Well, what's actually causing the mutations? And people say, well, they're just natural mutations. That's true. They are natural mutations, but what's causing the mutations is very likely has something to do with the sun, and most likely ultraviolet radiation coming from our sun is what caused these mutations in the DNA of the creatures here. The young sun, when it was earlier in its history, was very, very much more hot and much more energetic. So now it's sort of in its middle age, and it's not as energetic. And of course, here we are. We've survived just fine. But all the variations in our genetics over the billions of years that life has actually been here looks to me to have been caused in part by the ultraviolet energy being radiated by the sun and going into the cells and modifying the cells, making that, that creature different. And those modifications in the DNA get passed on when that creature reproduces. And then you have another creature that's born with the capabilities of the previous parent that had the DNA modified. So there's a lot of things, and that chain just goes on and on and on. It's really interesting how that works. But these red stars actually have lots of ultraviolet radiation that they give off. And that ultraviolet radiation, those ultraviolet flares, could mean that a species, a life form on planets around these types of stars might have a much deeper and richer evolutionary tree because of the changes forced by these ultraviolet flares. We think we've had a varied evolution, with like millions of species that have just come and gone. Well, there might be on planets around some of these stars. There might be, if life's there, you might have some extremely varied life with amazing history in their back pockets as well. It's pretty cool. It's pretty cool. There's a central star. I'm gonna stop the stack. I think we're probably at what? Are we almost at 30? Yeah, we've done 31. So I'm gonna pause this stack. I'm gonna save it.
You know, I see something in that image I don't think I've seen before.
Oh yeah.
Not sure what it is. The image is kind of hot and yellow.
Yes, it is.
You know, the green is kind of a yellowy green instead of that azure or cyan color.
Yeah. Well, it's just the way the processing happened here.
But down at about 4 o'clock, from the center of the nebula, there's a real bright patch. There's that red star just next to the nebula at about 4 o'clock, and then just to its left, there's a little yellow-orangey kind of oblong thing that appears to be part of the nebula.
You talking about right here?
Oh, 4 o'clock.
Oh, okay.
4 o'clock.
Oh wait. All right. I'm
Right
thinking.
there.
Sorry. I'm totally wrong. You mean here?
Yeah, right there.
Okay. So that.
Closer, closer, closer. Right there, just to the left of the pointer.
Okay. So this area right here.
Right there.
Interesting. Yeah, that's an interesting location. I've seen that on other photos we've taken. And remember, we're looking at it with a wide field, so a nebula like this isn't showcased very well. We need more magnification, of course, but you know, it does really show some really interesting features. And that's pretty cool. You can actually see the other elements to this, and those will get drawn out too when we actually do more processing. You know. So we're gonna clear this stack.
What's it first?
Because I saved it. And so we're clear. And I saved it, as exactly as is. And now we're going to get out of the live stack and go back to the photos. And go to 1 second exposures again. There's Dingo in the background having a dream. Okay.
Is he riding in asleep?
No, she's actually just laying there and being lazy. She's not running. She's just barking from a distance, I think.
I hear that.
Yeah. Okay. So now, let's do something else. I want to see, because right now I think that we're actually looking pretty up near the zenith right there. So, and we're right here looking here. I'm going to take us over to Deneb. Alright. Because this is just a beautiful location. And I want to go... I want to go to this location just a minute. We've seen Satyr. Isabella Melamed actually did some really cool work with Satyr. So we're going to go to here. We're going to go to the Pelican Nebula. Alright. And it'll probably go to Deneb as its star that's hunting for. But before I do that, let me just make sure I've got my 1 second. I think I did it, but you always double check. I do. Alright, so now we come back here. And we're going to now select the Pelican. And go to the Pelican. You can watch the telescope, and you'll see the telescope's going to tilt back even more. Alright, there it goes. And I'm going to imagine that we're going to see Deneb come in here as the main star that it's going to be hunting for. I believe that's Deneb. And to know
Sure
that,
is bright.
yeah, to know that for sure, we just have to look here. Yes, that's Deneb we're at right now. And then we're going to be dropped down to the Pelican here. Yeah, we're centered on Deneb. And then we run away, and make our way over to the nebula. You'll notice I'm doing the go-tos now. You know, I'm confident. I'm more confident with the go-tos now, Daryl. Okay, we're going to do a 22-second exposure on this. And go. We may have to just alter the position here slightly. Yeah, well, there's a nebula there for sure. Let's live stack it to see what we got. Excuse me.
Excuse me a moment. I'll be right back.
Okay. All right, we got us a nebula. Just one stacked image. Beautiful up here. And I know it doesn't look like much yet, but we're going to be able to pull out more detail here. Okay, you can start to see what we're going to be aiming for shortly. Okay. There we go. Now, look at that beautiful nebula. Isn't that beautiful? Hey, Martian. How are you? Yes, Martian. It's the Pelican Nebula. Well, my favorite solar system object is the sun. Without it, we wouldn't be here to have a favorite object. Actually, in truth, it's actually Europa and Pluto in that order. Europa because the ocean beneath the surface that might harbor life of some kind. And Pluto because of the literally frozen nitrogen surface. Io is a distant third, but it's still third. And the reason Io is in the list for me, Jupiter's moon Io, very small, lots of sulfur compounds, is that Io has an atmosphere. And when it's on the daytime side of Jupiter, that atmosphere is pretty plentiful. You wouldn't notice it. You wouldn't really notice it to be looking at it. But at night, what happens is when it goes behind Jupiter, the temperature drops so fast and so precipitously that atmosphere rains out as snow onto the surface of Io. and it ends up going away almost entirely, with only a few atoms left in the region around Io. And then when it gets on the sunlit side again, same thing happens again. Stars to percolate, and all these outgassing things can occur, and you get an atmosphere of atoms again that again goes away at night. So the atmosphere rains out every single night on Io. Very, very interesting. And the night is caused by not Io rotating, because Io's actually tidally locked to Jupiter. It's actually caused by the fact that the moon is so close to Jupiter that it only has one face facing it. So its day and night cycle is determined by when it goes behind Jupiter. That's night. Look at this, huh, Daryl? What do you think?
I think it's great. I see the pelican's head.
Oh, yeah.
And his beak going down to the lower left.
Yeah.
Top of his head to the upper right.
Yep. Let's see if we can get a little more out of this one. This really is not bad for having a nearly full moon out, you know that?
This is true.
Here we go. That looks pretty.
I always see his eye as the little dark spot there with the 4 stars.
This one? This is his eye. Are you looking at YouTube again?
Nope, I'm on your page.
Okay. So this is what you see as the eye?
Yes.
This is the back of the head. This is the pelican's beak.
Yes.
Yep. That's cool, huh? Oh, yes. Pelican is stunning. And by the way, this is at 43%. Let's actually zoom out to and look at the entire field, and then you'll see it, and you'll go, wow. And there you go.
The back of the pelican's head, yeah, is, you see it's a little brighter. It almost reminds me of the Cygnus wall in a way.
Yeah.
Which is over off of the coast of Mexico.
Yeah. I'm in the way. I just want to move out of the way. Yeah, but you can see some beautiful detail here. This is the North American Nebula over here. And this is the Pelican Nebula. And we decided to run in on the Pelican Nebula here. Really pretty. It's just really just beautiful. Wow. That's right, Vera. She says it's like watching a miracle, seeing the image stacked right before your eyes. Yeah, that's the new capability that I wanted to add to this observatory, because live stacking is unparalleled. You can't beat it. You just can't. So by doing this, it gives us the opportunity to actually see for ourselves what's going on in this nebula very quickly, and everybody gets to see it. It's not, you don't have to wait for it, It's a little bright. Let me back out of that. I might have to do this over. Yeah. Let me back out of this. I'll do this. Do this. Yep.
North American Nebula is supposedly visible to the naked eye from a truly dark location. Yep. I can't say I've ever really seen it. I might have seen the least little smudge there.
Yeah, I've actually seen it in the desert out there, and it's not. Again, it doesn't jump out at you, because there's so much Milky Way that you're not sure exactly what you're looking at sometimes,
Right.
Yeah, this is just, Yeah. And we're going to come back to look at other objects in this region as well. I'm almost tempted to look at the elephant's trunk, but I don't want to go to the elephant's trunk tonight. I do, very desperately, actually. but I'm not going to do it. I want to actually want to take advantage of some of the other stuff. Okay, we've stacked 22 images here. So I'm going to save the stack, pause it. Stack's been saved. And now I will save it just like you see it here. Okay. There you go. And now the image and the stack have been saved. They will be up there in just a few minutes. But there you go. Look at that. Wow. Absolutely beautiful. Yeah, I know. All right, so
Before you leave,
yep.
can you maybe goose it over just a little bit to the left where we can see Mexico and the North American Nebula?
Yeah.
And
that's where I'm
try to
going
keep
next.
the Pelican in the frame too.
Yeah.
I'd like to compare that red on the back of the Pelican's head to the Cygnus wall there on the Pacific coast of Mexico.
Yeah, okay. Let me get out of the stack. It's going to go away. But don't worry. I'm going to bring this down now to a little smaller. Alright. So, we're going to come over toward this side here in a minute. And let's see. Shoot. I gotta change my time here. Alright. Okay. I wonder if this will do it, Daryl.
I don't know.
Well, let's just take an image.
Take a picture and see, I guess.
I guess we can. Yeah. I will do 25 seconds.
I think it may have moved the Pelican off the screen, but we'll see.
Yeah, I don't see the bright star, but
See the Cygnus wall at any rate.
yeah. Ronald is here. Amanda Shaw, how are you? Nice to see you. I like that. Educate yourself, brain. Okay. So let's go to the live stack of this right off the bat. And that's the other one. Let's clear it. And we'll see that it's off to the right now. Wait, what happened?
Full moon's actually in the morning, Ronald. It's about 7 hours from now.
This is interesting. I definitely moved it over. So why didn't it? That's weird. It just didn't show up. Okay, let's go back to this. Alright, and let's get rid of this first. We're gonna clear this. Get all this for now. Alright, we want to bring it over, so Right?
You already moved quite a ways, didn't you?
I thought I did, but I don't know what happened. That was weird. It's a missing time thing. Oh no. Okay. I believe this is that star, and this is where those 4 stars are. Am I right?
I'm lost.
Okay. Okay, well, this is a universe. Alright, we'll try this. You know, when we get Starlink out there, you know, the other thing too that's going to happen is it's going to be a lot faster. Everything takes it's a 1 second delay. And unfortunately, because of the 1 second delay, I'm stuck having to wait like a few seconds, or, you know, a second for this to happen, and have
21st century problems.
Yeah, I know. I don't mind.
At least you're not having to do it via Morse code anymore.
Well, that's true. Just want to thank you guys for coming out here. This is really nice.
Looks like the sun's about to come up in France.
Yeah?
Yeah. I've had 24-hour Le Mans race on all day and all night. And
Wow.
going on nearly 11 here, so it's, excuse me, 7 in the morning there.
Okay.
And it's almost daylight.
Let's live stack this. All right. Okay. Cygnus Wall is just
Yeah, you got it.
on the edge, and the pelican that you wanted to see is there.
Uh-huh.
If you notice, we're looking at pretty much very similar structures.
Yeah. Just greater concentrations of mass in the...
In the wall.
Yeah.
Yeah. And what's the wall? The wall's this thing right here, and it's sort of off the screen, which is disappointing. When I do this and get this out of the way, you'll see that it'll fill the screen more better. Okay, so there's the Cygnus Wall. It's an area of intense concentrations of dark dust and hydrogen gas. And the hydrogen gas, of course, is excited to glow by the hot stars in this region. You can see these dark lines here. These are dark filamentary structures. These are dark nebula. There's dark nebula all throughout here, which is why this is dark like this. It's really an amazing area. And you know what I'm going to do is I want to kind of run north a little bit and stop. So I'm not going to save this yet. I'm going to actually head north. Let me
goose it just a hair farther east too.
Yeah, just a hair. I don't want to go too far. So we're going to do this. And you'll see, okay, we want this to go a little further this way and this to go up. All right, so what we're going to do is go do this. A little more maybe. Okay, and then we're gonna drop the telescope south a little bit. There we go, a little more. Just like in the large observatory, this is what I did. I had a telescope that was 35 feet long, a 20-inch diameter refractor, and I didn't own it. It was part of my university observatories, and we used that to actually do a lot of research. And moving a 10-ton instrument around is actually pretty unnerving, especially when things go wrong. Okay. I think this is good.
Ronald, what do you think the red color is from?
Ooh.
You should have learned this by now. You say it all the time.
Yeah, we do.
It's hydrogen alpha emission.
He was probably writing exactly that. Don't worry, Ronald. I'm gonna really, just, pound you in for that when I see you in Pine Bush, because you'll be there.
I can actually see the Gulf of Mexico in that first image right there.
Right there, yeah.
Little right there.
Yeah, this is the Gulf of Mexico. This is Mexico. But you'll see it better when I do this and Live Stacker. And I may have to clear the previous image because we had that, and it'll be a little more up and over to the right. All right. Oh, this is just so beautiful. I mean, when the first image comes in, it almost looks like the finished processed image. Isn't that cool? I just love how that happens. Look at that.
Hey, you got it.
Yeah, look at that.
Yeah, we could see the Cygnus wall very well, and still see the back of the bird's head.
Yeah. Let's
see how they both stand out.
Yeah. Okay, well there you go. So see, this is what SkyTour LiveStream is all about, guys.
That's a nice picture.
And the new techniques that we're using to actually do the live stacking, all these things, how does that work? I mean, actually, we're taking an image, then we take another image, and that image gets automatically aligned to the first. So it gets moved around whichever way it has to be perfectly aligned, and then the data is added together. And it does that over and over and over and over again. So it's like stacking all these images of your hand on top of each other. That improves the signal to noise ratio. And Isabella mentioned it in one of her Facebook posts that she put up there today. She looked at this data and said, wow, there's like almost no noise. That's true. And part of that is because of the process that's going on that I'll show you right now. If you look down this list here, these are the camera controls and everything else. But if you look down here, you'll see that the cooler is on. Cooler? What's that? Well, the temperature of the sensor is set at minus 10 Celsius. That's what I set it at. And it's at minus 10 right now. Okay? So we're able to cool the sensor down with a thermoelectric cooler. And by cooling the sensor down, we actually can produce imagery that has very little noise. And that's what we see here, very little noise. And what's the noise? Well, the noise is, when you have a highly sensitive camera like this one, then, as I pointed out earlier, this number here, the gain, can be the same as like the ISO. Well, we're running, say, at an equivalent of like maybe 60,000 ISO, maybe 75,000 ISO right now. It's a very sensitive camera. And we're doing a 25-second exposure. Well, if you just did one 25-second exposure, this is going to look at this whole image is going to look a little mottled. You'll see some mottling, 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 and that would actually, that'd be the noise coming through. But the more images you take, all right, then the less of that mottling can get through because it's being averaged out, and the data comes through fine. Like when we look at the Cygnus wall right here, okay, we see this beautiful Cygnus wall, this beautiful band of hydrogen alpha that we see here, okay. Well, that data comes in clearer and clearer and clearer. You see like all this data, you can see all the really neat filamentary structure in here. It's very obvious, but it might not have been so obvious. Then you got this guy right here. Look at this little line right here. This is a nice dark little nebula right here that's really set off from the rest of the nebula behind it. And it is behind it. This is in front of that nebula. The nebula's back here, and this cloud is up there. This dark cloud's there. So that's what we're seeing like when we see this stuff. Same thing over here. We have this beautiful band, of black dust right here. That's just like sitting right in front of the nebula, and it basically looks gorgeous. We have the same thing right here. Okay, and again, this material is this dark dust, molecules of carbon in general, and other compounds. But this dust was created in supernovae on the outsides of the very large red supergiants just before they exploded. And as they pulsated, when they start to use nuclear fuels of a different type, they make different fuels, and then there's shells around the core of these stars that start fusing stuff. So you have hydrogen fusing the helium in the core the very first time the star starts up. Then the helium builds up in there, and then the helium starts fusing into carbon and nitrogen, and you get oxygen atoms as well. And then in shells, successive shells like onion skin, you have all these other materials that are actually fusing in there, and they make heavier elements in the periodic table this way. That's one way. But when the core runs out of its main fuel, and there's nothing left to fuse, it usually stops at iron, number 26 in the periodic table. And when it actually stops at that point, the star collapses. The core collapses. That core collapse is actually something that happens in literally a fourth of a second. A giant star's core will collapse in a fourth of a second. And when it hits this iron in the core, that iron is not going to change into anything else. It actually rebounds. It bounces off that. And now you've got all this collapsing stuff coming in, and the inner core part is now shooting out at high speed because of the rebound, and it literally rips the star apart in the most massive explosion, or I should say, one of the most massive explosions the universe has to offer. The biggest explosion that we know so far is the kilonova, which is even more fantastical. But in the time that I've been telling you about this, you can actually see that this area here has gotten much clearer and more sharply defined. Look at that. Again, full moon is out, and we're able to acquire images like this. That's because of the filter system, as well as the darkness of the sky, in terms of, I should say, the transparency of the sky.
Martian, it stops at iron, and Mark, stop me if I'm wrong. Fusion stops at iron because it takes more energy to fuse than it releases. I think that's how they say it.
That's correct.
Yeah. And to get more energy, you need a supernova to do it. When you look at this, all this, the emission that you're seeing here is being caused by the star Deneb, is it not?
Yes, that's that's the popular thought right now. But that's not to say there's not other stars in here that are creating cavities of areas that are actually causing glowing to occur. Now, the other thing I was mentioning was that was the supernova, but before I was mentioning the shells. When those shells are depleted, okay, let's say we have helium burning into, fusing into carbon. Well, when the helium starts getting used up, the star begins to contract. And then when it contracts, more of that stuff in the outer area gets pulled toward the core, gets hotter, and now the next shell can start burning. So that makes the star blow up again. So that means over time the star does this. It pulsates, okay? And they go into a state where there could be what are called pulsating variables. And when they pulsate like that, sometimes when these stars get so big, these red supergiants get so big, their outer layers are so far from the center core of the star that the outer layers are almost gravitationally unbound, meaning they no longer attached to the gravity of the star. And it just takes the slightest little push, a little like an upsurge in some material that starts fusing to push an outer layer away permanently and forever. And many times in those far, far, far away outer layers, the temperature can be low enough that molecules can exist. So if you have carbon atoms out there in the farther reaches, those carbon atoms can combine and form a carbon-carbon molecule. And much of what we're seeing is that those carbon-carbon molecules. Now, there's other types of interstellar molecules as well that form. There's formaldehydes and other things out there. But the thing to understand is that this basically is soot. Like when you see soot coming off of a fireplace or lining a fireplace. It's soot, the same stuff. But the actual shape and makeup and the layout of the atoms in the compound that make this stuff are a little bit different than ground-based, because here it's in an atmosphere, and that has a tendency to include other atoms and stuff. But it's a little more pure out in these nebulae. These nebulae, they look dense, but in fact they are what we call rarefied gases, okay, and dust, meaning that there's not very much of it in a cubic centimeter or whatever of space. Let's go see where our live stack sits here. 22 of them. Wow.
I think that's a cool picture.
It's beautiful, and even with the full moon, I think this one is a keeper. We're going to be able to pull a lot of detail out of this. Look at that. Look at the pelican.
I see something there that I've never seen before.
What's that?
You may have pointed to it later. Down right toward the bottom, left to center of the screen, that dark line right there, yes.
Yeah, I pointed to it earlier, remember?
Yes.
Yeah.
Yeah.
That's interesting.
I don't remember ever seeing that before.
Well, this is just something. Yeah, and I'm going to keep stacking because, this is just a beautiful nebula. Look at this filamentary, feathery structure right here. Okay, it leads into the dark, and that's the thing. When we do this, that filamentary, feathery structure, that's actually the black material overlaying the nebula behind it.
Right.
It's not this filamentary stuff overlaying dark or nothingness. This is black material, black soot from countless supernovas.
Could you say that, like the little black tendril we talked about just now and you did before, could that be sort of like one of the pillars of creation?
Yeah, I mean, it's very likely that it could actually be a similar type of material. Now, the pillars of creation, of course, were, 5,000-6,000 light years away. And this is like, 1,500?
Something like that, yeah.
So we're talking about a tendril that's a lot closer to us.
Sure is pretty.
It sure is. Let me see if I can just play around a little bit here. It's going to be a little bright, but this is not permanent stuff. This is just, it's just playing with an image as it stands. It doesn't mean that the image is going to stay that way. I could have actually gone up more and gotten the bottom of the wall.
Yeah. But
it's good like this.
Oh, I think that's great. Yeah, if you do some post-processing on that, and I wouldn't be surprised if some of that brightness was due to the brightness of the full moon.
I'm sure it is.
Heck, that's a keeper right there.
It is. All right, we've got 29 frames. I'm going to let it go to 30, and then I'm going to pause it, save it all, and you'll have access to this very picture in about 45 seconds, I would think, after I hit save and you see it get up there. And it's going to be a PNG file. The raw file is going to be a stacked FITS file. FITS, that's an astronomical format. There are many FITS readers out there you can get. ASI makes a free program to use to read these FITS files. And you also have FITS Liberator, which is another one, which is free. You have, if you have Photoshop, you can actually get a plugin for Photoshop to read FITS files, and of course I did that because I want to be able to just load these stacks right into Photoshop. Now, the other thing I'll do at some point, if you're interested, is I'll take you into Photoshop with me and we'll do the processing so you can actually see what we do in Photoshop, because I think that's really another thing that's amazing to do. Now, here's the thing. If you remember when with SkyTour East, we took photos like this, and we just saw little tiny hints of the nebula. We didn't actually see the nebula really too well. Here we actually see the nebula very well, and we're not even processing it yet. This is just the rough processing done by the camera. Oh, you know. So this is something else, man. Really, really, really primitive. You know, we were doing it before, and this is just something different and new. You know.
Yeah.
Very, very happy about doing this. Ah.
That's beautiful right there.
It really is. And I also generate what's called a flat field. And I do it artificially so that I can get rid of the central brightness here, which is due to the moon and other things. And probably because of the way the cooler is operating. Without the cooler, this would be a useless picture. The cooler makes this noise-free, you know. So, anyway. Okay, so it's so painful to just like clear this away, but I saved this.
Aren't you glad you listened to me?
Yes, I am. We'll miss you when you're gone.
I didn't even have to say it this time.
Hey, it's okay. Alright, I'm just going to save one more time. Alright. Okay. And save exactly as seen. I know I did it. Alright, so now I'm going to get rid of this. And it's going to go away. And I'm going to go back down to the 1 second.
Get a finished image of that. Please share it with me.
Well, of course I will. I'll share it on Facebook. And this is where you say, I don't have Facebook. Yep, I certainly will. After all, you're the reason that we went and did this one shot. Which is great. Okay, let's go back to our beautiful oh yes, I have to do this.
Cocoon?
You got it. Okay, let's watch the telescope. It's gonna lean back even further. Here it goes.
Mark, I will be right back.
Okay. I hope you guys are enjoying this. Okay, here comes our program star that we use to do the leap to the other object. And we're going to something called the Cocoon Nebula. Now, I'm going to share something with you. I've never seen the Cocoon Nebula in the way that this location affords. So I have a feeling it's going to be something unbelievably beyond my expectations. So we're going to find out, and I'm really excited about this and nervous as heck. I just can't wait. Okay. This will be another 25-second exposure. Alright. 25 seconds. We're ready to go. And off we go. And then we'll live stack it as well. I take the first 25-second shot just to make sure that it's there. And then we can push process for a bit and make sure that everything I want to see is there, and then center it up if it's not. Okay, we're almost there with the first shot. And the farther north we go, the less the moon affects us, so that's good. There it is, right in the center. Look at that. Wow. Okay. Okay, we are there. So now let's go to the live stack on this and clear this, or else they'll just overlay each other, which is kind of weird looking. And there's the cocoon. And this is only a partial image of it too. This is only like after like a couple seconds, because it brought in the remainder of the last few seconds of the last exposure. Cocoon has some really interesting dark tendrils associated with it. Let's go see what we have. Yeah. Okay. Cooler's at -10. Everything is going fine. All right.
Okay, back.
All right.
There's a lot of star trails in that image too.
What do you mean, star trails?
Well, you know, lines of stars. Looks like. I'm sure they're
I
just
see.
superpositions, but
Yeah. Gotcha.
makes you wonder sometimes.
Yeah.
I know we've looked at, speaking of, in the Veil before, and
Yeah.
you'll see some star trains there that looks almost like they follow the shock front of supernova.
Well,
And maybe you should look at the Veil before you leave the area tonight.
Oh, the Veil is actually a little further south from us right now. I'm only just a hop, skip, and a jump from the elephant's trunk, you know.
Okay.
And the elephant's trunk on a moonless night, I have a feeling it would just be absolutely stunning, because it's mostly dark nebula that's silhouetted by hydrogen alpha regions behind it, and it's just beautiful. Let's go check this out. Let's go to 40%. There's the cocoon. There's a lot more to it in here. There's other stuff out here where you see a lack of stars. There's actually dark nebula there that's making it look like that's a lack of stars.
Right.
But oh man, I wish I was collimated. I wish this thing was collimated, you know. But it hit the telescope that time, and I think that's what caused this problem. I had it reasonably collimated on day one, but then in running without that dew shield, that thing that's sticking way off the top, I ended up that lens was sticking out, and the telescope banged into that when it went haywire. It literally went haywire. And I just thought that was the worst possible thing to happen.
You know, one thing with collimation too, if you ever fooled with Newtonian telescopes, it's an issue. The shorter the focal ratio, the more critical collimation becomes.
Yeah.
And, you know, you went from an F8 to an F2 system,
Mm-hmm.
and I know just with like a Dobsonian telescope, you get down to, my 16 inch is an F4.5.
Yeah.
And collimation is much more critical at F4.5 than it is, say, on my 8 inch, which is an F8 system.
Yeah.
That's one reason I like that red telescope so much, is it's much more forgiving collimation-wise.
Yeah.
And it's higher power. It's good for planets and stuff, too.
Okay,
But,
I'm gonna limited
light
12 of
bucket.
these.
That's what the 16 inch is for.
Yeah.
The collimation of it gets to be critical when you get down to F4, much less than F2.
Yeah. All right, I'm doing a 12 stack on the cocoon. Save it just as seen as well. When I say save it just as seen, these are not fully processed, but these images are actually like thumbnails that go in the directory. So when you go in and look in the processed directory out there in the link that I gave you to this location, server location, you'll actually see this thumbnail image, so you know, oh, this is the cocoon and everything, or that's this. Okay, now let's clear this guy and get rid of this. All this stuff's gonna be so much faster with Starlink, holy cow. Alright. Again, another. Alright. Okay, now let's go to what I really, really want to see. Coming up. We're gonna go. It's 60 degrees up. We're gonna go to the elephant's trunk. I hope it makes it. Okay. Telescope's on the way. We're on the way! We're using something called high precision pointing, so the telescope's going to find a bright star, as I mentioned. It's going to center the bright star, and once it gets the star centered, it will then proceed to, like here it is, just centering it, and once it centers it, it runs to, it literally star hops to the object of interest. And it's actually been, these objects have been showing up in the middle, right in the middle of the frame. So that's pretty good. This is probably very close to being in at least the darkest part of the sky from this location right now because of the moon. Okay, well, let's give it a shot. I just see stars. What else could there possibly be here? Huh.
What are you looking for now? The elephant's trunk?
Yeah. Okay. 25 seconds. And I'm going to go 370.
You know, another one that would be a really good fit for this focal length, it's getting to be that time of year, is the double cluster.
Yeah, as well as the Andromeda Galaxy. Mm-hmm. I'm really anxious to do that as well.
Yeah, heck, 2 degree field, you still won't be able to fit all of Andromeda in there.
No. Okay, let's live stack. I hope that we don't have to clear the last one. Okay. Alrighty. Wow. Here it is, right there.
Yep.
Wow. Okay.
So you just you did a go-to on Stellarium and went with what it showed you?
I did. I didn't even adjust it, and it was, look at that, it's almost exactly where it needs to be.
Yeah. You've got more of it going on over a little bit to the right.
Huh?
You have a little more going on to the right of what you're calling the elephant trunk.
Yeah. So I could actually move it a little bit more. So I can do that. And then just redo the stack.
Yeah, nudge it to the right just a hair.
Yeah.
Yeah, maybe down a little bit. You got some more dark nebulosity going on at the upper left.
I know. I gotta actually try and...
Like you did for North American Nebula, just go up a hair and to the right a hair.
So we're gonna go to 1 second here. I'm gonna kill the live stack for now. Okay. So I want to go up a little bit. About like that, you think?
Sure, why not?
And then I'm gonna drop over and pull more in from the right. Oops. My other right. Okay. One more jog. Okay, I think that's going to be the one.
Yeah.
And let's go and add the 25 seconds back. And then by adding 25 seconds back, that's going to give us, no, not milliseconds. 25 seconds. Okay. And cooler still at -10, that's good. Alright, we're taking that first exposure. Get the live stack going. It's only going to use the last few seconds. I'm going to clear it. Okay. Dead center. The live stack's in the way. That's why the dialogue's in the way. So I'm going to put it right here. And now we have it. We're gonna get a. You see the noise? Like, see how mottled it looks? That's the thing I'm telling you about. We're gonna get rid of that. Wow. And just wait till the moon's gone. It's going to be stunning. Okay, if you look up here, the upper left, there's this beautiful dark nebula up here. It crosses the screen over here. This is actually, this darkness on the edge is not from that. That darkness on the edge might be because the dew shield is also off center, because I also struck the telescope after the dew shield was in place at one point when it went haywire.
One man, Amanda, people are complaining about you. Please behave yourselves or we'll have to boot you.
Who are we complaining about?
Read the chat, Bobby Burgess. I don't want to ban anybody, but I will if I have to.
Now ease up on folks, one man. It's okay. We're all having a good time here. Let's see if I can get us a little bit more detail here.
I know you've shown the elephant's trunk in the past.
Yeah.
But it was at F8, and I don't think we saw that on the right, the part on the right at all.
We did not. We did not.
Or the dark stuff across the top.
Mm-hmm. Let's try the
Now the dark over on the right-hand edge of the image, is that vignetting?
Yes.
Okay.
That's what I was mentioning before. I added some sharpening here to the image.
Can you show in Stellarium real quick where we are now?
Sure.
That won't interfere with your work here, will it?
No. Because this is still going on in the background.
Okay.
Okay. If you look, all right, we're actually on the other side. Let me zoom out, show you where we are. It just takes so much time to do this because of this thing. All right, this is north. This is straight up. Okay, Cygnus is directly overhead right now, and we're actually looking down toward
Cepheus.
Cepheus right here. Yes.
Yes.
But Cygnus is at the zenith.
Yeah.
That's what I was saying. And we're actually right here, and we're looking kind of sort of toward the northeast. You can see the Andromeda Galaxy is right over here. It looks tantalizingly close, but we would have to turn the telescope pretty much toward the roof right now. It won't hit. You know, there's plenty of room, plenty of clearance. I've gone through all that trying to see if it would ever hit. It's not even close. It just looks like it might be.
That's fine. Yeah, I was trying to remember just where Elephant's Trunk was. It's really close to Cepheus there.
Right.
That upside down kind of kid's house shape you see, folks, that is Cepheus the king.
Mm-hmm.
And then there's Cassiopeia just to Cepheus's lower right, that crooked W shape. Cassiopeia is the queen.
Yep.
That W usually represents her throne she's sitting on. And her daughter Andromeda is just over there to the right where Andromeda Galaxy is.
Yep.
And the big square to the upper right of Andromeda is Pegasus, the flying horse.
Right there, yep.
Uh-huh. And then
and just
below...
a second. Hold on 1 second, Dale.
Yep.
This is the square that he's talking about right here.
It's called the Great Square of Pegasus.
Yep. So
and then down below Cassiopeia, below the double cluster you see there, is Perseus the hero. And if you ever saw the movie Clash of the Titans, that's what's going on right there. Cassiopeia lipped off about how beautiful Andromeda, her daughter, was, and pissed off Poseidon, or one of the gods, I think, or some minor goddesses or nymphs or something that were under Poseidon, about Andromeda's beauty, and it offended them. And Poseidon, or whoever it was, to make them feel better, he ordered that Andromeda be chained to a rock and fed to the Cetus sea monster, which is farther down to the south. And Perseus took on the mission to save his squeeze Andromeda, and they gave him a magic helmet and a magic shield and a sword, and he cut the Gorgon's head off, and he's holding Medusa. The Gorgon's head, Medusa, in his left arm.
Yeah.
And if you ever saw the old Clash of the Titans, the Ray Harryhausen special effects movie,
oh yeah,
that was telling that story right there.
Mm-hmm.
But anyway, thank you. Now I remember where the elephant's trunk is.
Yeah, it's right there at the bottom of the house, basically.
Yep.
And the iris is right there. Not 10 degrees away. About 15 degrees away. Yep. So let's see what we got now. Wow, look at that. There's a lot of data here. Look at this. This nebula is beautiful over here. How many did we stack so far? 22. I seem to always have that magic number 22 in my head, you know? We'll go to 25 and then we'll stop. I just want to get the noise as much further out as I can. Hey there, Laura Newbert. How are you? Well, thank you, Bobby. We'll be safe. We have a hurricane bearing down on us right now. It's supposed to strike tonight in the middle of the night. So I figured I'd better get this in case we're not here tomorrow. I think we'll be fine. That's good, Laura. This is just so beautiful. There's 25. So I'll pause it right here. Save it. I'm giving Isabella Melamed in Bulgaria. She's going to be going crazy because she's going to have like 5 major objects that she can have fun with. She does a lot of the processing for herself. You know, she has a lot of fun with it. Yeah.
I would like to see her work.
Oh yeah, she posted on Facebook, unfortunately. But if you connect with her in Skype, I'm sure she'll send you images through Skype. Okay, we'll be back to this. Uh-oh. Are you on? Here's a good example. Okay, you look at this image before it changes. Look at all the noise in it. This noise is what you get rid of by stacking images together. You know, the other images at the end look like soft and nice. This looks almost rough. Okay, and that rough look is because of the fact that it's noisy from not being stacked. But it has far less noise than it might otherwise have. You know. So let's go back down to here, and let's go look for something else. I like your idea from before, Daryl. We're gonna do it.
What's that?
We're gonna go to the Veil.
Oh, okay, cool.
Yeah. All right. So watch the telescope, folks. Over here, it's gonna come down.
Martian, you hadn't heard about the hurricane? Hurricane Henry, it's moving up the east coast. Well, it's not on the east coast yet. It's out in the Atlantic, but it's making a beeline for Mark tomorrow morning. Mark and Bill both.
Yeah. Well, more me than Bill, actually.
Yeah. I guess more Long Island than Bill.
Yeah.
Bill's location.
It's going to come up through Connecticut directly through Litchfield County. I'll be sure to take some photographs of the eye wall if we see it, but I honestly haven't seen the eye wall on the imagery lately, at all. The eye wall of the hurricane should be fairly well developed, but a hurricane of type 1, class 1, you may not have a very well developed eye wall. You know what we're gonna do? Let's just do a straight. Yeah, there we go. It's right there in the center, Daryl. Look at that. Beautiful. Yeah. I can do a quick stretch to see if our object's right there, and then just undo it. And now I can take our longer exposure and then live stack this. This is a supernova remnant, folks. It's actually the eastern side of a supernova remnant that actually makes a full spherical remnant. We have to remember it's in 3D. It's not a circular remnant. It looks like it, but it's a spherical remnant. Okay, so let's do 25 seconds here.
It's actually much bigger than the moon in the sky, too.
It's like 6 lunar diameters for the whole one, I believe, right?
Something like that.
Yeah, it's like 3 degrees.
The size of Andromeda.
Yeah, it goes like 3 degrees across the sky. Beautiful, stunning nebula. All right, this image coming in is going to be just a 25-second shot, and you can start to see it a little bit there. And if we were to process this, it's obviously with the moon, it's a little bit underwhelming, I think. But if we live stack it, you'll actually get to see the colors. The colors look beautiful in this gorgeous remnant. What happened? Oops.
Need to clear?
I do. I thought I did. And when that image is read out, we'll see the full image. Alright. Check this out. Wow. You'll see in a second. Look at this. Wow. This is beautiful.
Colors look like they shifted a lot.
Well, they did a little bit, but you see, this is more like it right here.
Okay.
Check that out, folks. That's a supernova remnant. So you can see it's curved because it was expanding from an area that's actually down in here somewhere. Okay, so it was actually spanning here somewhere and then out like that. Okay, where it went out to there. Now, one of the things you notice is that all along this area here, you see all these little filaments. Okay, those filaments are there because there was compression of the gas. Now, what happens is, as the star that created this was fueling itself with, hydrogen into helium fusion, okay, that star was creating a cavity in the interstellar medium, an area where it literally pushed out with its stellar radiation. It pushed out most of the material that was there. Any interstellar dust or anything was all pushed out. Other gas was pushed out. But then, when the star went supernova, okay, that supernova shockwave caught up to that outer cavity wall, which is expanding obviously a little bit, all right? And as it hit that outer cavity wall, it suddenly slams into all this other material in the interstellar medium out here, and then it starts slowing down, heating up, and causing gases to glow. The green is oxygen, the red is hydrogen. So this is basically how supernovas operate. They will actually carve out a giant spherical, shell around themselves, that these stars will. And then when they actually do go supernova, the supernova material moves out at millions of miles an hour, and it eventually catches up with that outer wall. All right, because it's going way faster. And when it hits that outer wall, it just slows right down, heats right up, the gas glows, and you get this look. Okay, these filaments. So, and because of the what we call it's non-homogeneity of the interstellar medium, it's not all the same everywhere. Okay, so because of that, we end up seeing also that these objects don't look like they're perfect. They actually have things that stick off and so forth. That's because there's knotty material, K-N-O-T-T-Y, knotty material in the interstellar medium that you can't see. And when this thing expands, it hits it and it kind of gets all messed up as it expands into it. And we're seeing a snapshot in time of this expanding remnant. And that's what's cool. So if you think about a star as making a cavity with its stellar winds, when it blows up, okay, that stuff moves out much faster. And when it hits that boundary where that cavity ends, this type of thing happens where the gas gets slowed down, hitting other stuff, and when it hits other stuff, you get friction and heating, and also you have other processes going on in there that will cause the hydrogen to glow and the oxygen to glow. And so that's how this is actually glowing. And all this time we're stacking, by the way. So see? So I'm spouting my mouth off, but we're actually doing a stack. We've already done 10. Won't that be fun to have fun with later? Yes, it will. Wow. As I started thinking about Daryl, I felt that the cavity process, describing that, is probably the best way to get this point across. Here we go. Look at that.
Yeah, it's great.
Wow. Well, we've gone for 2 hours, 21 minutes so far.
Yeah, I'm going to have to call it here pretty soon.
So am I. I'm going to be calling it. This is probably the last object. And we're going to revisit these after the moon is not showing up anymore. The monsoon season out there is coming to an end.
Here too.
We ended up getting a beautiful clear night out there. This is one of many to come. There's 300 clear nights a year out there. Oh, I'm going to have to go. See, my blood orange, black raspberry, sparkling water is empty. And by the way, if you get a chance, check out this on Discovery Plus. Check out Alien Invasion, Hudson Valley. It's a show, the documentary that we did. It's I didn't do it. The production company did it, but Ben Hansen, myself, and Melissa Tittle were the cast members, and we actually did some really good investigations in the Hudson Valley. And so far, people watching it say they seem to like it, so I think that's pretty cool. So if you get a chance, go ahead and watch it. It's on Discovery Plus, so it's streaming. You can watch it anytime you want. Now this is actually 40% in, so if we go to auto, you can actually see how big it is on the actual frame. Okay.
Martian, I don't know if it's my place to say. I have little or no doubt that Bill, New York Skywatcher, will be doing broadcasts during Pine Bush. I don't know any of the particulars, so Mark might know.
No, it's definitely a community get-together. Anyone can go. I posted links to get tickets on a number of Facebook locations. So it's definitely something that anyone can go to. I'll be speaking there. Lee Spiegel's speaking there. Richard Dolan's speaking there. And we're all good friends. We're thinking, because the telescope is working so well, we're thinking that while we're there, if we get a chance, we're going to stream and do a SkyTour LiveStream West from Pine Bush. It's really, really a great little conference. You know, it's only a one-day event, but it's just incredible.
It's only one day?
Yeah, I think it's the 4th.
Oh.
It starts in the early morning and goes into the evening.
Well, knowing Bill, he'll probably go all week, won't he?
Oh yeah, I mean they're coming. The whole crew's coming here. They're visiting here to check out everything that we do here. You know, I think he's just looking for more toys. The last time they all came over, I gave and Keith was here from P&K Space Imaging. I gave them all these little satellite models that we made for Google Earth. It was a Google Earth satellite. So we, hey Tim F, we did that, and then I gave them some meteor craters that we had 3D printed, and then lunar craters, I should say, not the meteor crater, but lunar craters. I did do meteor crater, but then Keith came back, and I gave him another model because I do have a visual effects company, and a guy drove from Los Angeles. He drove in his little tiny beat-up pickup truck. He drove this model out to me, and he said, "I was told you would like to have this," and I don't remember saying that I wanted to have it. But what it was I couldn't say no to it, because what it was the actual Jupiter 2 from the original Lost in Space TV series, and it was a casting from the molds that made that, and the casting itself, you know, it's worth probably quite a lot of money. I didn't want to spend the time to restore it or anything like that. Keith expressed an interest in doing that, and I said, well, go ahead. So I gave it to him, and if he wants to ever sell it, I said, all you gotta do, you can sell it, all, you know, but just remember, okay, you gotta split it with me. You know, if you get anything for it, split it with me, and before you sell it, okay, talk to me first, because you might be underselling it. You know, it's a valuable prop. So anyway, it was the original Lost in Space, you know, with June Cartwright, or what was the lady's name that was in that?
June
Lockhart.
June Lockhart, yeah.
Okay, yeah, June Lockhart. Billy Mooney.
She was Lassie's mom.
Yeah, that's right.
She was Timmy's mom.
Okay.
Yeah.
That's right, not Lassie's mom. That'd be a tough one. Look at this. Look how beautiful it is, guys. The noise is abating because of the multiple exposures. We're up to 26 stack of 26. This is really pretty. Really pretty. Hey there, Roni. How are you?
June Lockhart reminds me, if you ever watched the original Battlestar Galactica, the one from back in the late 70s.
Yes, I remember that one.
June Lockhart's daughter played, I can't think of her name now. She played Admiral Kane's daughter in the original Battlestar Galactica.
Okay.
She was blonde, really cute girl.
Okay. Hey there, SA. Satisfying animation. Yeah, you're a little late, but you know what? It's a stream. It's saved. You can go watch it. You know, we did a lot of really cool things. We actually got some neat stuff here. I'm going to do a stack of 30 for this object, and then that'll be that.
Yeah, I'm afraid I'm going to have to call it a night.
Well, you're just going to wait until I finish the 30th one, and then you can go.
I will.
See, it's at 29.
May I ask a question? I hesitate to even do this out loud, but do you have Isabella's Skype?
I have her email. So if you... I don't think Isabella would mind. Isabella, let me know if you mind if I share your email with Daryl. Because he'd love to see some of the images you are processing.
I would very much, Isabella.
Yeah. And you know what I love about Isabella? She's taught herself this. She's you know, she goes after these things in the same way that I go after these things. You know, yes, I work in the field, but you know what? There comes a point where you actually have to get down, sit in front of the computer, and actually start learning how to do certain things. And I'm also going to share with her eventually the Photoshop actions that I wrote for Photoshop for astronomy as well. And then she can start to do things short. She can, like, in other words, it's like a macro. You basically, there's certain things you do all the time in these images. Well, I made those things so that we could actually shorten the time it takes to do some of the processing. Okay. This was definitely going to benefit from a flat field. You see the glow in the middle? That's our moon. Okay, we're going to pause and absolutely save this stack. That's beautiful. Supernova remnant. And then I will take it and save exactly as seen. It tells you that it will save that too. Okay. This image will now be available at the link that is pinned in my Facebook page for Mark D'Antonio and the SkyTour LiveStream page with Mark D'Antonio. It's pinned there as well, so you can check it out. Okay, that said, we're going to clear this now, go back and prepare, because I just don't know when to quit, but I know I have to quit. I did make it clear that I was going to be doing this tonight, but I want to see.
I have to say, this turned out much better than I was expecting with the bright moon.
Yeah, well, and we are somewhat far away from it, right? So, but still. Alright, well, we're actually looking right at the zenith right now. So I think what I want to do is let me just get rid of this for a minute. Here. And that's the eastern veil, and this is the western veil. Why does it do that? Because it's so sensitive. Okay. The western veil on the western side here. This is a nebula that is like a short spindle, but it has some really interesting features. This is the overall supernova remnant. Let me just show it to you really fast. Again, in stellarium. Here's the overall supernova remnant. Right there. Now that's a spherical shell expanding out from the center of where this star blew up. It's about 100 light years across. It's about 1,600 light years away. It exploded about 8,000 years ago. Okay. This star here looks like it's in this side of the nebula, but it's not. It's actually only about 300 light years away, and the nebula is another, oh gosh, over 1,000 more light years beyond it. So it's actually just a line of sight thing, but I think what I'm going to do is I'm going to go to 52 Cygni. I did the eastern, I got to do the western.
Just one more.
Just one more, that's me. Okay, so the telescope is moving now, and which star is it going to pick? Is it going to go to 52 Cygni, or is it going to go to, okay, it's going to Algina. It's going up to Algina, and you'll see Algina appear here in a minute. Here it comes. Algina will get centered, and then off it goes to 52 Cygni. And I can actually, I should do it now just to show you. This 1 second delay is making me crazy. Alright, so I do this now. This is going to really push everything. So as we get in now, you'll actually see when we get to where we're going, there it is. And it's going to center it up now. There's the Filamentary Nebula right there. This is that star 52 Cygni that I told you was only about 300 light years away. This is about 1,500 or so light years away right there. Ah, God, that's beautiful. And by the way, this is a 1 second exposure. Can you imagine? 1 second with the moon out, that's why it's so blue. But we'll do a 25 second exposure. And I will undo this now that we know we're in the right place. We're going to see what's called the witch's broom and everything.
Isabella, I'm going to try to answer her question.
I didn't see it. What did she ask?
Why it seems to you there are places with more globular clusters. A long time ago, an astronomer, I want to say it was Shapley, but I'm not sure about that. He was doing a study of globular clusters, and he noted that they tended to, they were, now Mark calls them halo objects now.
Yes.
But he noted they tended to concentrate towards Sagittarius. And this was one way, if I remember the story correctly, that he deduced that the center of the galaxy was towards Sagittarius. And it was like the center of the halo, and helped deduce the real layout of the Milky Way galaxy by the distribution of the globular clusters.
Right.
They do tend to concentrate toward the sky and toward the center of the galaxy, around Sagittarius, Scorpius, Ophiuchus, and stuff like that.
Yeah.
That's the short form. I would need to verify who that astronomer was. I want to say it was Harlow Shapley.
Yeah, I think it was Harlow Shapley, but I don't remember myself actually. I'm just going crazy looking at this beautiful
What is?
This Western Veil. Again, there's that star that's much closer to us. This is the remnant that's much further away. Same thing happened here. The star was making this cavity around itself, and then after the supernova occurred, that material went out really fast, and when it collided with that outer wall, it actually ended up causing the gas to really get hot and glow, and it's really a process that is responsible for making other stars, making the nebulae visible, of course. But if it's also doing this, it's also possibly kicking off planetary formation somewhere in there. Now, the planets wouldn't be able to have atmospheres in such a hot environment, because if the gas is hot enough to glow, then it means that the temperature is pretty high. Okay, but this is just a location where it's temporary. That heated region is just temporary. Over time, that will actually level out, and the temperature will drop. This is just looking so pretty. We've stacked 7 of these so far. This is going to be one of the, even with the moon, it's actually one of the biggest set of object nights we've had.
Just past Meridian.
Okay. I got a meridian alert, which is fine. For where we're pointing. We just passed the meridian with the telescope. So this image tells us that when you pass the meridian, for this particular object, that's the best you'll see it. Because as it passes the meridian, it means it's actually basically as high as it can get in your sky when it passes the meridian. So this is a good thing to hear. Let's see what this does. Yeah, this actually adds more saturated color. Let's get this back to where we were.
Yes, it was Harlow Shapley.
Okay.
1917.
Awesome.
Over 100 years ago.
During World War I. Wow. And just so you know, guys, the moon being out does degrade the image quality to some extent. That's because the moon is illuminating the sky. The sky has got hazes in it, particulates. That's what we're seeing in this right here. We're seeing the moon reflecting off of other particles in the night sky that we normally don't see and normally don't get picked up in our imagery. So we're getting additional quote-unquote noise from these reflected particulates of the moonlight. That's why the sky looks like it has a glow around the moon. You know, it can't reflect off of gas. It has to reflect off of particles, particulates. So that's what's going on. Wow, I'm. Has anybody out in the chat? Have any of you actually gone off and done a look at the directory to see if these files are out there? When I do a lot of them like this, it takes some time for them to get out there. Oh man, I spent all day battening down the hatches. I got rid of anything that could fly around and move and become a projectile. Except my recycling bin. I haven't done a thing to that. Huh. Oh, it'll probably be fine. What was that link you were putting up?
I'm sorry, say again?
What was that link you were putting up?
That's an article about Shapley
Okay,
and Delivery clusters.
That's what I thought. Okay, cool. Ay, 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 this is just endlessly fun.
Let Isabella read it at her own leisure.
Okay. And, if you look at what happens here, and you don't know unless you actually examine the distances to all these stars, but some of the stars seem like they follow the expansion of this supernova remnant. Daryl was alluding to some of this before, but as it reaches that edge of that cavity that it carved out, and collides with the interstellar medium, it could spark star formation along the way. And sometimes in these remnants, you'll see strings like pearls, a string of pearls along the nebula, and it could be that you're looking at exactly that, a compression sparked star formation episode, right? From the compression of the material. This star formation, these things right here, like for these stars right here, they seem to conform with this curved piece of the nebula. So could it be that these 4 stars were formed because of this? Maybe. We'd have to check out every one of these stars and get their distance. They could be vastly different distances. Boom, that your theory's out in the water, out of the water. But maybe not. You don't know. We have to see. You have to check it. So that's the kind of thing that astronomy is about. You see something and say, "Ooh, let's check out and see if that's true." The nice thing is that if you add that kind of desire to look that up, these stars can be identified. Okay, and you can then figure out exactly where you're looking in the sky, exactly what stars those are, and then you go to these databases online. One's called SEDS, and another one. These are all. There's Aladdin, and there's a number of the others. And there's portals that actually allow you to look at the stars, identify the stars, and get all their information. And they usually give you the distance to the stars as well, and their speeds through space, where they're moving, and that's very important too. Because if the 4 stars are kind of moving in the same direction, that lends credence to the fact that they were formed in this shock front. You know, if they're going in all these different directions, well then maybe not. But you have to just look it up and see. So it's really cool, you know.
You know what really strikes me about that
What's that?
image? The top part of the witch's broom there.
Oh, up here, you mean? This is the witch's room down here, guys.
Like a funnel.
Yeah,
No,
right
the
here.
top part.
Oh, you mean up here?
Yes, it looks like a funnel, like a rope tornado almost.
Yes, it does.
Yeah. Like it's twisted tight.
Yeah. Sorry. Can't believe I just yawned on you all. My mistake. I'm sorry. I'll never do it again. That's probably a lie. I don't want to yawn on anybody. Wow. See, because the moon's out, this bottom part here doesn't look very visible. But after processing and get rid of all the blue and everything, final processing, then it'll be fine. However, at this point, we should have 25. Yep. I'm going to pause this. Okay, 26. I'll take it. I will save this stack. You'll see the saving goes there. So now it tells you it's 26 frames, and it is now saved and heading up to the cloud as we speak. Now I'm going to save this object just as you see it here. There we go. And then it'll tell you that it's saving there. Snapshot in progress. And there it is. Okay. So we're going to clear this. Well, actually, yeah, I have to because I got to shut it down. Okay, so that was the last object. I want to thank you guys. If you want to stick around and see the close process, how we close down, you're welcome to. I disconnect the camera and I shut the camera program here. I will in a sec. And it was a really good night. Man, it was a good night. Okay. And then I will disconnect the stellarium system. You do these things.
Yeah, this turned out better than I ever could have imagined with the full moon like that.
Yeah, I was very pleased. But the beautiful sky out there doesn't hurt, you know.
Yeah. You mentioned a while ago the monsoon is breaking. I'm seeing signs of it here as well.
Yep.
It has been like 90 or in the 90s here lately,
Yep.
and today it was only in the low to mid 70s.
Okay.
It was a beautiful day, and then it finally did. We had some storms come in late.
Okay.
I saw the moon and Jupiter, and I took a peek outside a while ago, and the clouds had come back again. But it's supposed to be back in the 90s for much of this week. But you know,
Okay.
I can just feel it here that the weather is changing, and you know, the monsoon is wrapping up. It always ends about Labor Day here.
Yeah.
Yeah. So we'll have weeks on end of sunny weather.
Yep.
It does that here.
Yeah.
After Labor Day, it'll just day after day, weeks on end of mild sunny days and clear, cool nights until eventually it snows.
Okay. And it's all ruined. I just bought 3 tons of pellets that are getting delivered Monday, but I doubt they're actually going to show up Monday. It has to be the day after, and the hurricane will still be leaving some remnants, so I don't think we're going to see those pellets on Monday.
Say that again?
I bought pellet heating fuel, 3 tons. And it's supposed to be delivered Monday.
Pellet fuel?
Yeah, pellets for a pellet stove.
You're breaking up.
All right, hold on a sec. I bought pellet fuel for pellet stove that we have. I bought 3 tons of it.
Wow.
Yeah, and it's three big pallets, but I don't think it's going to get delivered Monday like it's supposed to. Okay, next I'm disconnecting the scope. No, I'm not. I'm actually parking the scope. So I hit park, and now watch the telescope. Okay. Okay, look down here. The controller says slewing, and you watch the scope move down, and it goes to a position that is clear of the roof. Okay, and then it will stop there. And when it stops, okay, right there, this message down here will say, you're there, turn off the scope. And that's cool. And now what we do next is we just come in and I bring up my program that I wrote. I don't need it to be pretty. And I shut off the power to the telescope. But before I do that though, I'm going to just make sure that I disconnect from that, from the focusing system. Alright, and now I'll disconnect the scope here. And
Telescope disconnected.
And I don't know if you heard that, it said telescope disconnected. And then I can quit this program. Yes. And now I only have 2 things left to do. Number 1 is turn off the power to the pier. And you'll know that's happening because you look at the handset down there, it says scope park, turn the scope off. So if I come over here and I hit that enter key, you'll see that go blank. Boom. Telescope is now off. And the only thing left is to shut the roof. And I do that next. And you'll see the roof come up. You'll see the roof coming over now. Alright. There it goes. I still can't get over it. It's like 2,600 miles away and it's still working. It's just beautiful. And you might say, well, isn't that a spider web? Yes, it is a spider web. That's right here. Okay.
They can take care of that while you're there, too.
Yeah. Actually, Tara was out there and she looked and she said she didn't see it. So, that's okay. So, this was an amazing night. and I want to thank you guys for coming here and enjoying it with us. And as of now, the next clear night, I think we're going to wait another few days just for the moon to get past full, so we'll have some dark sky time as well. But I want you guys to go to that link, take down all the pretty pictures, and if you want to take down those FITS files, the FITS files, go for it. I can tell you this, tomorrow is going to be a long day of processing for me. If I don't lose power from the hurricane, I'll be hunkered down here in this bunker, all right, doing all that processing of everything, the final processing. All right, so this is what it looks like when it's just regular. Okay, you can see my portholes up there. I've got portholes for windows like a ship. Those are battleship portholes, and this office looks like a battleship actually. Girders for the ceiling, you know, and like I said, that's SkyTour LiveStream East telescope right there. It's in here because we're redoing the building out there because we outgrew the dome. So I hope you guys had a good time tonight. I sure did. These are some of the objects we've taken before with East. Okay, and then of course the dumbbell nebula. See that right there? It's really pretty, you know. But look, I think that we'll be back soon enough, and I'll let you know in a Facebook post or what have you. I don't know how the notifications in YouTube are working anymore. I just don't get it. They don't seem to be working, and I don't understand it. Well, anyway, you guys have a good night. Daryl, thank you for sticking out for the last few minutes. I know that you're tired.
Sure. Thanks for having me on. Good night, everybody. Thanks for coming.
Good night, everybody. We'll see you later.